In February of 2026, one of the biggest memory chip makers on Earth quietly did something that would have been unthinkable a few years earlier. Micron, a company that's been selling memory to regular people for over 2 decades, killed its own consumer brand. Crucial, the RAM and storage brand sitting inside millions of ordinary laptops and desktops was simply retired, not sold off, not rebranded. Discontinued so the company could redirect its factories towards something far more profitable, feeding AI data centers. No press conference. No dramatic announcement. Just a quiet corporate decision that most consumers never even noticed because most consumers had no idea crucial memory was inside their machine in the first place. That's exactly what makes it worth paying attention to. The changes reshaping the electronics industry right now aren't happening in headlines. They're happening in decisions like this one, small, procedural, easy to miss, and enormously consequential. If you've ever bought a stick of RAM to upgrade an old computer, there's a decent chance you've used Crucial without even thinking about it. And now it's gone, not because people stopped wanting it, but because a company decided ordinary consumers were no longer worth manufacturing for. That one decision tells you almost everything you need to know about what's happening across the entire electronics industry right now. So let's talk about how the race to build AI is quietly making your phone, your laptop, and your next gaming console more expensive, and in some cases, worse. Here's the mechanism, and it's simpler than you'd expect. Every device with a processor, your phone, your laptop, your game console, needs memory chips, mainly a type called DRAM, to function. For decades, a small handful of companies made that memory. Samsung, SK Hynix, and Micron control more than 95% of the world's supply between them. That part hasn't changed. What has changed is what those factories are being used to build. AI systems need a specialized, much more advanced type of memory called high bandwidth memory, or HBM. It sits directly next to AI chips inside data centers and feeds them information at extreme speed. And here's the part that explains this entire story. HBM is dramatically more profitable to manufacture than the ordinary memory in your laptop. By some estimates, 2 to 3 times more profitable per wafer. So when a memory company has to choose between building chips for your next phone or chips for an AI data center, the math isn't close. Every factory that gets converted to HBM production is a factory that stops making consumer memory. And that's exactly what's been happening, at scale, for the past 2 years. Let's put some numbers on this, because the scale is genuinely startling. HBM now consumes roughly a quarter of all DRAM manufacturing capacity worldwide, up from practically nothing just 2 years ago. As a result, DRAM prices climbed by roughly 170% over the course of 2025 alone. Some 2026 trackers show further jumps of up to 80 or 90% on top of that. NAND flash, the memory used for storage, jumped more than 60% in a single month at one point. To put that in perspective, imagine if the price of flour or gasoline jumped by that much in a matter of months. That's roughly the scale of disruption happening to a component sitting inside nearly every piece of consumer electronics on the planet. And it's not just prices climbing, it's supply drying up entirely. Reporting in early 2026 found that major electronics manufacturers were receiving only 50 to 66% of the memory chips they'd actually ordered. Not delayed, not back-ordered. Simply not available, because the factories that would have made those chips are now under contract to AI companies instead. Here's a number that puts the scale of AI's appetite into perspective. One widely cited industry estimate suggests that a single AI infrastructure project, OpenAI's Stargate initiative, could, at peak construction, absorb close to 40% of the entire world's DRAM output, not 40% of AI-related memory. 40% of all memory chip production on Earth, from a single company's build-out. Think about what that actually means. Every phone maker, every laptop maker, every game console maker, every car manufacturer that uses computer chips, all of them, combined, are now competing against a slice of demand from a handful of AI companies large enough to swallow nearly half the planet's memory supply on its own. So who's actually feeling this? Beyond the abstract idea of prices going up somewhere, start with laptops. Multiple manufacturers have publicly warned that 2026 could be one of the most expensive years for consumer electronics in recent memory, quite literally. Dell's own chief financial officer told investors that memory costs were escalating at rates the company had never seen before, and that those costs were being passed directly to consumers. Analysts broadly expect electronics prices to rise somewhere in the range of 5 to 20% this year, specifically because of memory shortages, with the memory itself being well above 80% more expensive. To make that concrete, a basic 16GB RAM upgrade kit that might have cost you around $50 a couple of years ago has, in some markets, climbed well past $200 for the exact same product with no improvement in performance whatsoever. You're not paying more for something better, you're paying more for the same thing because the factory that makes it would rather be making something else. And it's not limited to laptops and desktops. Smartphone makers rely on the same DRAM supply chain, and several have already signaled that future phone prices will need to reflect rising memory costs. Even industries you wouldn't immediately associate with AI are affected. Modern cars are packed with memory chips for infotainment systems, driver assist features, and engine management, which means automakers are now quietly competing with AI hyperscalers for the exact same production lines. Then there's gaming. RAM shortages have pushed up the price of gaming PCs, graphics cards, and even game consoles because all of them depend on the exact same memory chips being diverted toward AI. Graphics card prices, which had only just started stabilizing after the previous shortage years, are climbing again. And this time, industry watchers say it's not primarily about the GPU chip itself, but about the memory soldered onto it, which is competing for the same production lines as AI accelerators. One detail that captures the irony perfectly: Valve's long-rumored Steam machine, a project that finally has the software and hardware power to succeed, unlike its failed first attempt back in 2013, now faces a new problem its predecessor never had to worry about. Back in 2013, the original Steam machine failed for very ordinary reasons: underpowered hardware, a fragmented mix of operating systems, and prices that couldn't compete with a game console. This time, Valve has solved all of that. It has the technology figured out. What it doesn't have is control over its own bill of materials, because the memory chips it needs are being pulled toward AI data centers instead, a problem no amount of good engineering can solve. And then there's a trick worth knowing about, because it's happening quietly and most people won't notice it: shrinkflation. Rather than raise the sticker price on a device and risk losing customers, some manufacturers are instead quietly reducing the specs: less RAM, less storage, while keeping the same model name and the same price tag. Industry analysts have openly predicted this will become common through 2026. So the laptop or phone you buy this year, even at the same price as last year's model, may simply come with less inside it than you'd expect. Small manufacturers are getting hit even harder than the giants. Raspberry Pi, the company behind the popular low-cost computer boards used by hobbyists, schools, and small businesses worldwide, publicly described the memory shortage as painful after being forced to raise prices in December. A company like Raspberry Pi doesn't have the negotiating leverage of a Dell or a Samsung. When memory gets scarce, giant companies get priority. Everyone smaller gets whatever's left over, at whatever price the market demands. Of course, every squeeze has a winner on the other side of it, and it's worth naming who's actually benefiting here. The same three companies controlling the world's memory supply, Samsung, SK Hynix, and Micron, are posting some of the strongest profits in their history, precisely because they're selling less consumer memory at lower margins and more AI memory at dramatically higher ones. This isn't a story about an industry losing money. It's a story about an industry becoming enormously more profitable by deciding who it wants to sell to, and that decision just happens to leave ordinary consumers on the losing end of the trade. You might be wondering, haven't we seen chip shortages before? The answer is yes, and that's exactly why analysts say this time is different and arguably more serious. The 2020 to 2022 chip shortage, the one you might remember affecting car prices and game console availability, was driven by a temporary shock, pandemic disruptions, factory shutdowns, a sudden spike in demand for home electronics. It was painful, but it was always expected to correct itself once supply chains caught back up. And it did. Within about 2 years, prices and availability largely normalized. This shortage is structurally different. For one simple reason: it isn't being driven by a temporary event. It's being driven by permanent multi-year capital investment. Hyperscalers like Microsoft, Google, Amazon, and Meta have committed hundreds of billions of dollars to AI infrastructure, money that's already contracted, already under construction, and not going anywhere regardless of what happens to the broader economy. Memory manufacturers have responded by locking in long-term supply agreements directly with these companies, sometimes for years at a time, guaranteeing AI infrastructure gets priority access to production capacity before anyone else even gets a chance to bid. There's also a physical constraint that makes this harder to fix than past shortages. You can't simply build a new memory factory overnight. A modern semiconductor fab can take 2 to 3 years to construct and bring online, even once a company commits the capital. So even if a memory maker decided today to build new capacity specifically for consumer chips, that supply wouldn't reach store shelves for years. And by then, AI demand may have grown even further, absorbing that new capacity too. In other words, the 2020s chip shortage was a traffic jam. This one is more like a permanent lane closure. The road has been structurally rebuilt to send most of the traffic somewhere else, indefinitely. So when does this actually end? Here's the uncomfortable answer: nobody's entirely sure, and the estimates keep getting pushed further out. Some analysts expected relief by 2027. More recent forecasts from companies inside the industry, including one of the 3 dominant memory makers, have suggested the shortage could persist past 2030. As long as AI memory continues earning 2 to 3 times more than consumer memory, manufacturers have very little financial incentive to reverse course. The economics simply favor AI, and they're likely to keep favoring AI for as long as the AI boom itself continues. If there's a silver lining here, it's this. Some analysts are advising consumers to buy the electronics they need now rather than waiting, since prices are broadly expected to keep climbing rather than fall anytime soon. Not exactly a comforting piece of financial advice, but an honest one. It's worth asking whether this is actually a bad thing or just an uncomfortable one. From a purely economic standpoint, resources are simply flowing toward whatever generates the highest return. That's how markets are supposed to work, and AI infrastructure genuinely may turn out to be one of the most transformative technologies in decades. The frustrating part isn't that AI is winning the competition for these chips. It's that most consumers never got a vote in that competition, and won't find out they lost it until they're standing in a store looking at a price tag that doesn't make sense anymore. Step back, and the pattern connects directly to everything we've covered in this series. The hyperscalers spending hundreds of billions on data centers, the helium and energy shocks rippling through the chip supply chain, and now this. They're not separate stories. They're the same story, seen from different angles, an industry-wide reallocation of the world's most advanced manufacturing capacity almost entirely toward AI, and almost entirely away from the ordinary consumer electronics that regular people actually buy. Micron didn't kill the crucial brand because people stopped wanting affordable memory. It killed it because, in the current economy, building for use simply isn't as profitable as building for AI. And until that math changes, expect more of the same, quietly, gradually, one discontinued product line and one shrinking spec sheet at a time. If you found this video interesting, do me a favor and hit like, drop a comment, and subscribe for more videos like this one. I'll see you next time.